Hello, my name is Ahmed Mukhtar and welcome to Dr. Networks. This is a free CCNA course that we are offering from Dr. Networks. And if you want to keep yourself updated on our videos, do subscribe and share this because sharing is caring. So where did I came up with that line? I don't know. Okay, so today is lecture number 2 of the module 2, or module 2, and we're gonna be going through what are trunks and what are access ports. We're gonna go through this topic, and we're gonna go, okay, trunking is something that we're gonna be learning first, and then we're gonna be seeing, okay, what is the protocol actually that is used in the trunking, and that is the 802.1q protocol. So we're gonna be going through that as well. And what's the deal with the native VLAN? Okay, that's a good topic. There it is. We'll be going through these 3 topics, and here we go. Okay, the first slide that we're going to be going through is the access port. An access port has N devices that attach to it and can be part of only one data VLAN and one voice VLAN if present at a single time. So to toss some sense into that, let's just consider, first of all, I have a switch that I have ports configured with, the first port is configured with VLAN red. Now, in reality, you don't have colors, you have numbers, but for education's sake, I'm going to be saying it's colored. So you have the second port in VLAN blue and so on and so forth. So as soon as I connect this IP printer, this is an IP printer by the way, you connect this device towards this first port, it is in VLAN red. Okay, so now it can talk to all VLAN reds, meaning if it sends a broadcast, the broadcast is received by the switch, and the switch basically sends that broadcast to all the red ports now. That's pretty straightforward, and this is called an access port for, for this end device. This is an access port for the printer, and it's in VLAN red. Similar will be the case for this guy. This is an IP camera. So I've just connected it to VLAN blue, and now it has access to all VLAN blue ports. Means if it's in the broadcast. So this is pretty simple and straightforward, but a little bit of confusion comes up when I have a voice phone, IP phone, between a PC. Now, how do they work? Now, to just elaborate that a little bit, they have 2 cables. One cable is run from the switch towards the phone, and as you can see, the rear end of the phone, this is the first jack, Ethernet jack, and you can plug the switch's cable into that. And the second port is basically that goes towards the PC. Now, without diving too deep into this, I'm gonna be emphasizing only that they run CDP. Now, via CDP, this phone actually discovers its voice VLAN from the switch, because CDP is a protocol of discovery. That's what the name stands for, Cisco Discovery Protocol, and they discover each other. This phone, the switch says, "Okay, I've discovered an IP phone," and the IP phone says, "Hey, can you just give me my VLAN, the voice VLAN that you're using on your infrastructure?" And it just gives that VLAN away, and it uses that VLAN for data packets. And what happens with this dude? Well, it gets treated just like these guys. If this guy was connected towards this red interface, this guy is gonna get the same treatment as the end host ports. But the catch here is now you have 2 VLANs running on a single port. One for the data VLAN and one for the voice VLAN. So next up is trunking, and let's jump into that. Okay, up till now we've been talking about a single switch, haven't we? What happens is this guy sends a broadcast. I'll say this is a red host, and it sends a broadcast. It gets received on all the red ports. Now, what if I ran out of ports on that switch and I needed another switch, and I would have some guys of the blue and the red and the green VLANs residing on that switch, and I want to be able to communicate between switch A and switch B the same way I do on a single switch. So how do I do that? Well, that is where the trunking comes in. Trunking, aka tagging, passes VLAN information between switches, period. Well, this is actually a very precise definition of trunking. We will go into the technical details on the next slide, but bear with me. Here comes the red VLAN sending a broadcast as it always does. Let me just clear this up. It sends a broadcast, and the broadcast gets received on the red port, and the switch takes off his spectacles and says, okay, let me just grab my spectacles and see, okay, how many ports do I have that are configured for red VLAN? Oh, there it is, 1 and 2. So I'm going to be sending that broadcast out these ports, right? That's pretty much obvious by now. Now, what if some red users are connected here? How do I send the same broadcast to them? Well, that is where the trunking comes in, and the trunking is gonna allow me to communicate with other hosts that reside on the other switch. Here's how that happens. Now, on the trunk, when I'm sending that broadcast, let me change my color. When I'm sending that broadcast packet or frame, I'm gonna be tagging it or coloring it, in this case, by a red flag. I'm saying, okay, I'm sending switch B, I'm sending you a frame or packet that basically belongs to VLAN red. Switch B gets that packet or frame and said, okay, I see that frame, and by the way, it's a broadcast, so it's all F's in the destination MAC address. And this shim, this header basically tells it, okay, so I'm gonna strip it off. I see you want to go to the VLAN red guys, so I'm gonna take off my spectacles now, and I'm gonna be seeing, okay, which ports do I have in red? I'll be saying, okay, I have 2 ports in red. I'll be sending that broadcast out my red ports. Oh, there is no red guy connected here, but this is how trunking works in general, and this happens in layer 2. By layer 2, I means they get injected inside the layer 2 frame. I'm going to be showing you in the next slide. So this is just a general overview, and vice versa. If switch B wants to talk to switch A from any VLAN of red, blue, or green, similar process, a similar case is seen in those circumstances. So if I'm sending a blue packet, wait a second. So if I'm sending a blue packet, means a broadcast is come up from the blue guy, and then I'm going to be tagging with the blue color and saying, okay, I'm sending you blue. Switch B, it's your responsibility to untag it, technically untag it, and see, okay, yeah, okay, so I see, this is, wait a second, I see packet that is tagged blue. So what I'm going to do is I'm going to strip that blue off. I know that you want to go to the blue ports, and I'm going to send that broadcast to all the blue ports. So this is what happens, and this happens vice versa for every other VLAN that you allow on the trunk. So let's go to the technical details behind the scenes, what happens, and what is the protocol running behind the scenes for trunking. So moving on to the technical details of the trunk, we have that 802.1q protocol running behind the scenes. What this is actually the trunking protocol that allows your switches to communicate, just like we have the protocols of TCP, IP, and so on. So the switches pass information between each other using the official language of 802.1q. The good news is, and that's a great news actually, that this is an industrial standard. So if you have a Cisco switch on this side and an HP switch on this side, so they can still communicate between each other because it's an industrial standard protocol. Now, we have done a lot of broadcasting examples. What I will be telling you right now on the trunk behind the scene, what happens as I'm sending the packet out, as I'm sending the packet out like this, I basically insert a tag of the VLAN number that tells the other switch that, hey, you have to send this frame, this packet, or this broadcast message towards those specific VLANs, that specific VLAN. That in our case, that may be 10 or 20. So as I'm sending the packet out, I'm gonna be inserting this VLAN tag. Like if the blue VLAN is sending something, I'll be inserting the VLAN 10 tag here in the Ethernet frame and sending it out towards switch B. The switch B gets it and untags the frame. And it knows that, okay, you want to go to VLAN 10. I'll be sending that frame, if it's a broadcast, I'll be sending that frame out towards the blue guys. So, by the way, if it's a broadcast, this destination MAC address is all Fs, and the source MAC address is the MAC address of the one PC or end device that is originating the broadcast. So behind the scenes, this actually works. I'm gonna be showing you a Wireshark capture right here of VLAN 10 communicating over the Ethernet trunk and VLAN 20 communicating over the Ethernet trunk. So that is it with the 802.1q protocol, and more on that as we go towards the lab. And one last topic is the native VLAN. So let's look into that. Okay, so as we talk about trunking, the native VLAN concept is designed for packets that come untagged on a trunk link. Meaning, to really understand native VLAN, just consider this scenario. I mean, this is highly unlikely nowadays that this is gonna happen. This ain't gonna happen. But still, to understand what a native VLAN is, we gotta understand the concept behind it. So this is just a concept video. So let's say you have some legacy devices connected on the trunk, and the trunk also connects to two brand new switches that need to exchange VLAN information. So I have a hub in between. Now a hub is a layer 1 device, so it doesn't understand anything of layer 2. Like I said before, the trunking is basically the VLAN tagging is basically a layer 2 protocol. So this is a layer 1 device, so it doesn't understand. It just regenerates the frames. So what happens if these guys wants to talk to someone on the blue VLAN? How will I do that? Well, that is actually where the concept of native VLAN comes in. Whenever a packet that is untagged comes inwards towards a trunk, it will be tagged, allocated to a specific VLAN. Meaning, if I assign a native VLAN ID over here, like 10, now 10 is our VLAN ID of the blue guys. So whenever it sends a broadcast, the broadcast comes into the trunk, and the switch basically in the back end tags it inside that, okay, this frame came in without any tag, and I was expecting a tag, but if it's untagged, I'll just assign it to VLAN 10, and that broadcast just goes towards the VLAN blue or VLAN 10 users. So this is actually what a native VLAN is. It's designed for the untagged packets that come in toward from the trunk. Okay, exciting stuff here. We just gone through access ports and trunking. You've seen how the access port for data and voice VLAN work, how the trunking really works, and behind the scenes, the 802.1q protocol, how does it insert a header of a VLAN tag, and then we saw what is the use of the native VLAN. More on native VLAN soon, because I'm making a video on native VLAN and their use cases, because there aren't many use cases nowadays of native VLAN, but there are some funky scenarios there where you could use native VLAN. It all depends upon your need. Well, I hope this has been informative for you, and thank you for viewing.